Okay, so here we go. The last skills question. So you flicked over to this one and you see the function f is defined by f of x equals 3 minus 2x over x minus 5, and you're asked to find the inverse of this function. So inverse functions, we're hoping you've seen this, we're hoping you know how to do it, because it's one of these ones you'd never figure this out yourself on the day. You got to know that we're going to start off by isolating x. So we're going to do it step by step. We multiply across both sides by the x minus 5, so you get y times x minus 5 is equal to 3 times x minus 2. You're going to expand the brackets. Yx minus 5y equals 3 minus 2x. You're going to rearrange. Okay, so now what have we got? Well, we got anything with an x term on the left hand side. Okay, we're going to factorize out our x. If x times y plus 2 is equal to 3 plus 5y, and what we're going to do is we're going to divide both sides by the y plus 2. We're going to get 3 plus 5y over y plus 2. And then this is where you do this unusual thing here, where you can say like the x's and the y's swap over. Or more kind of officially what you're going to say is you're going to replace x with f of x, sorry, f inverse x, and you're going to replace y with x. Okay, so your answer is f inverse x is equal to 3 plus 5x over x plus 2, and that's worth 5 marks.
So this one's on a 0-3-5 scale. So partial credit here is for an attempt to rearrange for x. So if you just got as far as the second line where you moved across the x minus 5, that would get you the partial credit there for 3 marks. Okay, so if you are manipulating your original function to try and isolate the x on its own, you get partial credit for this question.
Okay, thanks very much. Okay, so there we go. Now, some of you wouldn't have been certain of how to do that question because maybe you haven't come across inverse functions yet, or you've seen it once and you just forgot about it. Okay, but again, right, you can have a look at part B, and it says it gives us a different function, the function g. It says as a domain -1 less than or equal to x less than or equal to 8. It is linear from -1 comma -9, or -1 -9 to 2 0. Okay, so you can see it's upward sloping from, we say, our first point down here, -1 -9 to 2 0. Okay, and again it's upward sloping from 2 0 to 8 4, but you can see it's at a different angle. A sketch of the graph y equals g of x is shown below. Write down the range of the values of g. Okay, the range of g. So for this, like, this is one of these ones that if you just kind of think about it for a while and say, okay, well, what's the range? Well, the domain relates to the x-axis, the range relates to the y-axis. So it's just the range is from -9 to +4, because it's corresponding to the domain that we're given. So -9 less than or equal to g of x less than or equal to 4. It's a 5-mark question.
So it's on a 0-3-5 scale. Partial credit here is very straightforward. If you got -9 or you got 4, you get partial credit here. You need both of them to get your full 5 marks.
Okay. Okay. So in some ways, it's an easy question, but in other ways, we know that maybe some students mightn't have managed to kind of figure out what was being looked for there. What's happening next here is we have a composite function. We're looking for f after g of x. So this can be written in different ways. The notation can be written in different ways, but it all means the same thing. F after g of 8. Now, again, one of these ones that you could be looking at thinking this is difficult, but maybe, hold on, maybe it's not. When x is equal to 8 in the function g, we know our y value is 4. So we have the point 8, 4. Okay, so our initial input is 8, our initial output is 4. So what am I going to do with that? Well, I'm going to use that initial output of 4, and I'm going to make that my input into my second function. My second function is f. So I'm back to f of x from my part A. My initial output is 4. Now that becomes my secondary input. So f of 4 is equal to 3 minus 2 times 4 all over 4 minus 5. F after g of 8 is equal to -5 over -1. It's equal to 5. And that was a 10-mark question.
So this one's been marked on a 0-5-8-10 scale. So low partial credit is for getting that first correct output. So the G of 8 is 4. So if you have that, that's low partial credit for 5 marks. Your high partial credit is substituting into F. Okay, so substituting that value into F. And that would be 8 marks for your high partial credit. So that we've added a note on this just to make it a little bit clearer. So if you had G of 8 correct and you subbed it into F, you would get your high partial credit. If you wrote G equals 8 and put it into F, then we're allowing that for low partial credit. So just be careful that if you got your initial output wrong, but you then substitute that into F, you can have low partial credit there. But there is a note on the scheme that you will be able to see about that as well.
So, Andrew, am I right in this? You're saying low partial credit, if they say f of 8 is equal to
Yeah.
3 minus 2 times 8
Yeah.
over 8 minus 5.
Absolutely. Yeah.
Okay, great stuff. So we're on to our last part. Now, the last part, okay, some students will know what to do here and others might not be sure. Because what you had to do was you had to show the coordinates of each point at which the graph meets or cuts the x-axis, okay? So that's of the inverse, g inverse x, okay? So you might be saying to yourself, how am I going to do this? But remember, if you don't know what to do what you know. You're asked for the inverse function. So we know that this guy here is our function g of x. We know that we can get the graph of the inverse by doing a transformation axial symmetry through the line y equals x. Okay, so what do? We go out at 90 degrees. So if I take a point here, the point 84, I go out to the line y equals x at 90 degrees. I go out the same distance the far side, and I'm going to get a point over there. Okay, so this point here is going to be the image of the point 84. Okay, now I do that for my 3 important points on the graph, and I have the shape of my inverse. Now I ask myself, okay, where is this going to cut through the x-axis? Okay, show the coordinates. And do I need to know that? Well, I do need to know it here. I have the point 0, 2, where it's going to cross my y-axis, because I know that when I go from a function to its inverse, the x's and the y's switch place. So if I call this one x1, y1, you can see that they've switched place over here to be y1, x1. And do I need to have one other one? I do. I'm kind of I'm nearly losing track of myself here, but I have it now. I'm back on track. So 0 minus 6 or 0 negative 6, let's call it x2 y2, and here I go over here. I know they're going to switch place here, so I'm going to have negative 6 0, and that's going to be my point, and that's for 5 marks.
So this one's marked on a 0, 3, 5 scale. So partial credit is for the correct shape or correct points. Okay, so if you have, so there's 3 things we're looking for here. If you have one of them correct, you can have partial credit on this one. So if you had the shape wrong, the shape wrong, but you had the 2 points right, then you could have partial credit. If you had the shape correct, but you didn't note on the points, you could still have partial credit. But for all 3 bits need to be correct to get your full 5 marks.
Okay, Andrew, thanks very much. Would you believe it? We're at the end of the skills question. I wonder, are there a lot of students out there now who found question 6 difficult, but now when they look at their marks, they say, actually, hold on, I actually didn't do as badly as I thought there, because if they got something down here for these questions, they're probably going to have stumbled onto a good few of the marks, even if they weren't certain of what they were doing. Okay, so we've finished our skills and we're going on to our problem solving questions. And our first one is going to be question 7.